Welcome to all for today's session. I am Ramesh, working as an assistant professor in the Department of Aerospace Engineering. In today's session, we are going to deal with the fundamentals of UAV, in which we are dealing with the specific topic called core components of UAS. The core components of UAS, that is the unmanned aircraft system, form a complex generation of aeronautical, electrical, software, and communication systems working together to enable remote flight operations. Fundamentally, a UAS consists of four primary components: the unmanned aerial vehicle first, the second one is the ground control station, GCS, the third one is the communication link between the UAV and the GCS, and finally the fourth one is the payload, which varies depending on the mission objective. Each of these components plays a vital role in ensuring that the system operates safely, effectively, and autonomously or semi-autonomously. Starting with the unmanned aerial vehicle, this is the flying portion of the system, and it is often categorized into fixed wing, rotary wing, or a hybrid vertical takeoff landing. The UAV includes key subsystems such as the airframe, which provides the structural support, propulsion systems. This is usually called electrical motors or internal combustion engines designed to generate the thrust. Next, flight control surfaces are rotor systems. They are for maneuverability, and onboard avionics, which consists of sensors, processors, and actuators. One of the most important subsystems within the UAV is the autopilot, which receives the control from the GCS or control inputs, and as well as it receives the control inputs from the ground and executes the pre-programmed flight missions. Embedded within the UAV or navigation and guidance system, typically combining global positioning systems, that is called GPS, as well as the inertial navigation systems, INS, magnetometers, and barometers, allowing for precise geolocation and flight stability. Additionally, onboard batteries are the fuel tanks serve as the power subsystems, supplying the energy to the motors and electronic components. Next, the ground control station, this is called the GCS. It serves as the command and monitoring for UAS operations. Depending on the complexity of the system, a GCS can range from a simple laptop-based interface to a sophisticated cockpit-like station with multiple screens and joysticks. The GCS displays real-time telemetry data such as altitude, speed, battery level, GPS location, and health diagnostics. It allows the human operator to input mission parameters, manually control the UV, monitor the camera feeds, and adjust the system settings. Often, the GCS are also equipped with software for mission planning, which allows user to define waypoints, geofencing zones, and emergency return paths. The communication subsystem is the backbone that links the UAV with the GCS, enabling command, control, and data exchange. This communication can be line of sight using radio frequencies such as 2.4 gigahertz or 5.8 gigahertz, or beyond visual line of sight, which typically involves satellite communication called SATCOM. There are two main types of communication. One is command and control. Generally, it is represented by a symbol like a C2 for flight operations. And the second one is the data link for transmitting payload data, such as video or sensor readings. Redundancy is often built into communication subsystems to avoid data loss, signal drop-ups, or interference, which is crucial for both the safety and the mission success. Another critical component is the payload, which is the part of the UAS subsystem that performs the mission-specific task. For surveillance missions, payloads often consist of high-definition cameras, thermal images, or lidar sensors. For agriculture use, multispectral or hyperspectral cameras can help in crop health monitoring. In delivery drones, the payload would be cargo bay or package delivery system. Scientific UAS may carry air quality sensors, atmospheric pressure devices, or radiation protectors or detectors. The payloads are often modular, allowing the same UAV platform to be adapted for multiple applications. In addition of these four main components, modern UAS integrate supporting systems such as collision avoidance sensors, typically ultrasonic infrared or vision-based to detect and avoid the obstacles in real time. Then fail-safe mechanisms like return to home, geofencing, and onboard store systems, onboard store mission logs and payload data. While some high data or high-end systems even include onboard artificial intelligence modules that enable the edge computing for real-time decision making and image analysis without needing to send the data to the DCS. Furthermore, the software architecture running the UAS is which is equally crucial. Open source platforms such as the PX4 or Pilot are commonly used for economic and research zones, while proprietary software is preferred in commercial and military grade UAS. So this is about the today's session. We will see with a different topic in the next class. So thank you for watching this video. Thank you all.